Okay. Good day, students at home. How are you doing? I hope all of you are keeping safe at home. My name is Mr. Raphael and I'm still your mathematics teacher. Today we are going to start with a new topic, which is circle geometry. This topic is actually divided into two sections. We have the chord property and the angles properties. But we are going to start with the one that I have not taught you. It's one or two of the most challenging questions that students usually face in exam because they don't know the theory. And since they don't know the theory, solving questions on circle geometry is always difficult. So I'm going to try as much as I can to explain in detail of this. So we're going to start with the first theorem, which is theorem 1. And the first theorem says that the angle which an arc of a circle subtends at the center is twice that which is subtends at any point on the remaining part of the circumference. So this theorem 1 is telling you that when you draw a circle, and this is a radius of a circle which touches the circumference, so this line is actually the circumference of a circle, and this thing is called the radius. Now any angle that is subtends here, if you get another angle from the same arc which it comes out, this is the arc in which these two angles are coming out, that this angle and this angle, that when you multiply this one by 2, you will have the angle that is here. So if you take a look at this, it says AOB, so which is this angle that is here, AOB is this angle, is equal to 2 times ABB, that is ABB. So what it means is that if here is 5, if I want to get what will be here, I will times this one by 2 to get what will be here, and here will be 10, that is 2 times 5. So let's look at this small example here. They say find the lettered angle Q. Find the lettered angle. So they are asked us to find this Q. So it's very simple. Because we have 41 at the circumference, we are looking at the angle at the center. And remember we said the angle at the center is 2 times the angle at the circumference. Therefore, for me to get my Q, angle Q will be equal to 2 times 41. So Q will now be equal to 82 degrees. So therefore, I'm plotting the angle Q. Now, let's look at another example. Example 2. Example 2. They say find the value of T and the U. So there is something I did not explain in this one. Now look at this. It goes up, right? It goes up. So I want you to use the same ideology to picture this one. Look at this. Look at this one. Two of them face the same side when you draw the angle. So for me to get my T, I will still follow the first theory, which says the angle at center is twice the angle at the circumference. So 135 is at the circumference, while T is at the center. So therefore, for me to get T is going to be what? T is in the center, which is what? 2 times that which is at the circumference, that is 2 times 135. And when you multiply 135 into 2, this is 0, this is 67, which is 270. So when you say 2 times 135, it's going to give you 270 degrees, which means I have gotten my T. But remember we have U. So if you take a look at this, this is already a circle. What is angle at a point, which is at a circle, is 360 degrees. For me to get U will be U plus T is 360 degree. Why? Angle at point. So therefore, I've gotten my T, so U will be equal to 360 minus T. That is, U is equal to 360 minus, my T is 270. And when you subtract, I will do it here, so I will not waste the ball. So 360 minus 270, 0, 13 minus 6, that will give you 7 plus 7 is 14, 7, 8, 9. So 90. So that will give you 90 degrees. So Therefore, I will say that U is equal to 90 degrees. Theorem 2. Theorem 2. We have so many other questions on Theorem 1, but we are coming to that later. Theorem 2 says angle in the same segment of a circle are equal. Angle in the same segment of a circle are equal. So look at this. Now look at S1 and S2. They are in the same segment. So they are in the same segment. Now this is the segment in which they are coming. This is the arc in which they are coming out from. So let's call here AB. So these two arcs produce this angle at this what? Circumference. So but this angle and this angle are the same. So when you draw this come down. If you also go from A again, you touch the another circumference, come back. Anyhow you want to do it, provided that it touches the circumference and come back to the same arc. So even if I do it like this, I will still come back here. Any of these angles in this segment are equal. So it means that if here is 5, it means that this one is 5 and this one is also 5. If here is 10, here is 10, here is another 10. So which deposit what we say S1 is equal to S2. And which deposit what we say that when you multiply this one by 2, when you multiply this one by 2, we have that which is at the center. So look at this. We are asked to find the value of what? P. Find S in terms of P. So which means make S the subject of the formula. Two of them are in the same segment. So therefore we can say that P is equal to 2S. But because we are asked to make S the subject of the formula, you divide both sides by 2. So when you cancel, therefore S will be equal to P over 2. We solve the question. So for today, we have come to the end of today's topic on circle theorem. We are still going to continue with Theorem 3, Theorem 4, Theorem 5, Theorem 6, and so on and so forth, maybe in our group chat, or when we also have time, we still continue by teaching it. So we are going to stop here. I'm going to give you an assignment in our group chat, so that time we still continue.